Good morning, students. Let us continue the chapter Atomic Structure. In 1911, Lord Rutherford, a scientist from New Zealand, was performing an experiment to find out the arrangement of electrons and protons in an atom. Where is the electron and where is the proton present in an atom? He performed the activity, it is called alpha particles scattering experiment. In alpha particles scattering experiment, he took a very thin gold foil. Very thin gold foil. It is of thickness 0.0004 centimeter. Very thick gold foil he took, and this foil was bombarded by alpha particles. It is important to know what are alpha particles. Actually, alpha particles are positively charged particles with 2 units positive charge and 4 units mass. Alpha particles were made from helium atoms. When helium atoms loses 2 electrons, it forms alpha particles. It has 2 unit positive charge and it has 4 unit mass. When the performance was done, he found something, and here is the observations of alpha particle scattering experiment. Most of the alpha particles passed straight through the foil without any deflection. In the diagram we can see most of the alpha particles, these are the alpha particles, and these particles are passed undeflected. A small fraction of them were deflected from their original path. We can see here are 1, 2, 3, 4, 5, 6, 7 alpha particles, but only 1 and 2 were deflected with a small angle, and very few are reversed back, bounced back. It was very surprising. When you have any ball and throw the wall, it will reflect back, but here 1 out of 12,000, 1 out of 12,000 reflected back. It was very surprising. On the basis of the above observation, he concluded that most of the space in an atom was empty. Most of the alpha particle passed. That means most of the space in the atom is empty. There was a heavy positively charged mass in atom. A positively charged mass in atom. It is positively charged because alpha particles are positively charged, and some rays were deflected. That means it is also a positive charge. As we know, same charges repel each other. Alpha particles are positively charged, so it is also positively charged. The positively charged mass is very small in centrally located, and this mass is located at the center of the atom, and it was named nucleus. This was the achievement of this alpha particles scattering experiment. By this experiment we come to know about the nucleus. Based on his experiment, Rutherford suggested a model for the structure of an atom. According to it, the nucleus is a centrally located positively charged mass. Centrally located, that means nucleus is present in the center of the atom, and it is positively charged. That means it has positive charge, and the entire mass of the atom is concentrated in it. The whole mass is in the nucleus. So it is the densest part of the atom. This whole part is empty and it is the densest part. Size of the nucleus is very small compared to the size of the atom. We can consider a circular stadium, cricket stadium or hockey stadium, and if we take a cricket ball or hockey ball and put at the center of the stadium or the playground, this is the condition of the nucleus in the atom. It is very small. In the outer circular part, there are electrons, and these electrons revolve in circular orbits, and these circular orbits are called cells: K cell, L cell, M cell, and N cell, and so on. An atom is electrically neutral. Atom is electrically neutral because atom has same number of electrons and same number of protons. The number of electrons is equal to the number of protons. Protons have positive charge, electrons have negative charge, so atom is electrically neutral. Students, this model is very much similar to the solar system. In the solar system, the sun is in the middle. The sun is in the middle, and the planets are revolving around it. So it is very much similar to the solar system. Let us see in the diagram. This is the diagram of solar system. The sun is at the center, and planets are revolving around the sun. It is very much similar to the atom. The nucleus is at the center, and electrons revolving around the extranuclear part in the circular paths called cells. And position of the electron and proton: electrons are outside and protons are inside the nucleus. Now the question arises: the mass of an atom was considered to be entirely the mass of the nucleus, that is protons, because protons are present in the nucleus. Electrons have the negligible mass, but it was found that nucleus had a greater mass that can be accounted by the proton. That means nucleus has the mass greater than the mass of proton. That means there must be another particle that is present in the nucleus and the atom. This third particle is also present here, and this is present in the nucleus. It was found that it has neither positive charge and nor negative charge. That means it is neutral. That's why it is named neutron. In 1932, James Chadwick discovered the subatomic particle and called it neutron because it has neither positive charge nor negative charge. And regarding mass, its mass was found to be almost equal to that of the proton. Its mass is proton's mass is around 1.672 into 10 to the power minus 24 gram. Its mass is slightly more. Its mass is 1.676 into 10 to the power minus 24 gram. Let's see the properties of neutrons. Mass we have seen. Electrically neutral because it has no charge. Atoms of the same element may differ in the number of neutrons. Atoms of the same element, for example, carbon 6 12, carbon 6 14, they are the atoms of same carbon element, but they have different neutrons. Atomic number is same, but here the mass number is different. I will explain later on. And this difference is due to the difference of neutrons. They form the isotopes. These are the isotopes. Let us recall the properties of subatomic particles. Electron symbolized as E minus 10. Its charge is 1 unit negative charge and mass is 9.1 into 10 to the power minus 28 gram. This is negligible. Proton, it is denoted as P1 plus 1. Here plus 1 is the charge and 1 is the 1 unit mass. Its mass is 1.6 into 10 to the power minus 24 gram. Neutron, it is denoted as N01. Here 0 is the charge and 1 is its mass. It is equal to the mass of the proton, 1.6 into 10 to the power minus 24 gram. But it is slightly different. It is important to know that hydrogen atom, hydrogen has only one proton and no one electron and no neutron. So we come to know the discovery of neutrons and the Rutherford atomic model. In the next class I will explain you the structural stability of an atom. You have to do You have to write the observations and conclusion and Rutherford atomic model in the classwork notebook. Thank you. Have a nice day. Have a nice study.